welcome to today's FDTD Satellite Applications webinar. Today we're pleased to have Mike Jurowitz and Dave Riddell, Sue's in State College and New York City, except it's not New York City. That office, though, presenting on the December 18th, 2019 Snow Squall event where both offices issued snow squall warnings. Next slide, please. This is part of a series of satellite chats on GOES applications. We're always looking for speakers. So if you have an idea, email me, Scott Lindstrom, or you can email Dan Banacos. Next slide, please. Just some guidelines. We'll have about 20 minutes for the speakers. These are two speakers. We'll see how they do. Then we'll follow by Q&A. You can always submit Q&A through the webinar as well. Don't press hold and mute when you're not speaking. Now take it away, Mike.
Okay, so can everyone see the screen now?
Yes, I see your slides.
All right. So first off, I appreciate Dave and I both appreciate the opportunity to show some stuff about a pretty high-profile snow squall event we had in the Northeast back in December, and hopefully the folks on the line can get some little tips and tricks to help them when they're faced with this phenomenon at their own office. Okay, so I'm going to do the Pennsylvania part of the event, and I'm going to pass it off to Dave in the WFO Brookhaven, and he's going to talk about the squalls as they move down through New Jersey and into the New York metro area later in the day. So I'm just going to start out with a brief synoptic overview going into the event on 18 December. We'll go over some mesoscale nuances of the event itself as the squalls developed. I'll have a few concluding thoughts, and then I'll pass the baton to Dave. So I'll start out with a conceptual model. Pete Banacos up at WFO Burlington, Vermont was one of the original pioneers in the Weather Service in really studying the snow squall phenomenon and getting some work published. And he's been instrumental in getting us to the point where the Weather Service now issues snow squall warnings. And this is a conceptual model, and it's kind of a busy slide, but the main point is there really are a lot of similarities between linear warm season convection, almost QLCS type events that we get during the warm season with regards to the wind orientation and the instability out ahead of the line and the different shear components. So this really is the cold season analog to severe weather, and it really can be very, very tricky, as you'll see as we go further on in the talk here. So a brief synoptic setting going into the event. There's a Channel 9 mid-level water vapor loop you'll see on the left, and then a 500 millibar analysis on the right. And the Northeast was squarely on the cyclonic shear side of a digging 500 millibar trough that morning. You can see the digging nature of the trough pretty well on the water vapor animation. So we go a little bit lower in the atmosphere. Now we're going to look at Channel 10, the low-level water vapor channel, which senses a little bit lower. You can see down to maybe 850, 875 millibars on many days with the weighting curve of that channel. And then there's an 850 millibar analysis on the right. And pay pretty close attention to the next couple slides. I have annotated on a dashed line 850 trough axis there at the 850 millibar level that early that morning at 12Z was coming into far western Pennsylvania and New York. It's kind of a lower level reflection of that digging shortwave aloft. Now let's step a little further down in the atmosphere to 925 millibars in the surface. So at 925, that same reflection of the same system is a little bit further upstream, more along the PA-New York border. And then as you look at a surface analysis at the same time, the surface run actually goes back across Lake Erie and into northern Ohio. So consequence of that, and I'm going to show soundings here on the upcoming slide, is you foresee an environment where the colder air at the upper part of the boundary layer around 850 to 800 millibars is coming in out ahead of the colder air closer to the surface in the lower part of the boundary layer. So that's going to really act to steepen the lapse rates and enhance the instability that this weather disturbance has access to as it comes east. So you can see the soundings here from Pittsburgh and Buffalo at 12Z, and in particular, the Buffalo sounding that was a little bit deeper into that air mass just ahead of the front where the cold air was coming in and the upper part of the boundary layer. Pretty steep lapse rates in place, all the way up to about 700 millibars. So for the cold season, pretty decent amount of instability there to tap. And then these are some simulated reflectivity images that an early morning forecaster, or maybe mid to late morning, would have had to look at from the HREF that morning. So this is two of the components of the HREF. This is the simulated reflectivity they were showing was going to be in place at 15Z, which is 10 a.m. local time. And you can see the discrete cells. So indication there could be some heavier snow showers or squalls. And certainly by 18Z, that development is continuing, and it would continue downstream as the day went on. So a little bit of a clue, too, from the HREF, there could be some interesting snow shower and snow squall activity. And with the next slide, what I'm showing here is a loop of the snow squall parameter. We talked about Banacos and the snow squall conceptual model from all the good work that he did at the beginning of the presentation. One of the great things that came from that work was the development of a snow squall parameter. Many are familiar with supercell parameter during the warm season. And this tries to look at some of the best indicators of snow squall potential, the orthogonal orientation of the wind component to the boundary, the level of instability you have, some lift components and that kind of thing. And so the red and orange shading shows some pretty high values of the snow squall parameter as it loops through the day across Pennsylvania and eventually toward the coastal plains. So the high-res models were certainly picking up on this potential. So what I'll do now is I will show some MRMS loops. So this here is a reflectivity at lowest altitude. These are actually the actual radar from about 14 to 19 Zulu that day. So from 10 a.m. local, actually 9 a.m. till about mid-afternoon. And you can see the cellular nature, and in some places are kind of linear in others, of these snow showers and squalls as they move across Pennsylvania. And at first glance, just looking at the radar, it's not completely obvious which ones are the ones to hone in on. So it demonstrates the complexity of these snow squall. So I'll step through these next slides a little bit more quick. This will be the same, it comes up here in a minute, from multi-radar, multi-sensor. You can look at the height of different reflectivity DBZ contours. Snow squalls being a low-level phenomenon during the winter, we look more at 18 to 20 dBZ and maybe up to 30 dBZ, what the heights of those are, to get an idea of where the most robust snow showers and squalls are. And if I move over here, you can see the legend on the right. You can see some green shading in some of the broken snow showers and the linear features coming through northern Pennsylvania. So that indicates, this scales in kilometers, that the 18 dBz was up to, in some cases, 4 to 6 kilometers above ground level, which is on the order of maybe 12 to 15,000 feet. Wouldn't be much for the warm season, but that's pretty good. That's a pretty good height for the cold season. So, again, some indications that there are some taller, more robust snow showers in this line. So, looking at the 18 dBz and 30 dBz, the heights of those contours in MRMS can be a tool that can be used at WFOs. So now we're going to go into some more radar stuff. On these two slides here on the left, this is a regional radar curve that we, and I'm sure many other offices have experimented with same, where the actual yellow and darker green shading is down as low as 20 to 25 dBzs. And when you get a 25 or 30 dBz snow echo, that starts to get your attention as a pretty intense feature. So as compared to the default curve, it gives us a little bit better, again, indication of where the more intense snow showers or squalls may be. And these are echo tops that are looping on the right-hand side. And the blue shading here shows where you've got 10 to 15,000, even higher tops to some of these cells. So again, it gives you an indication of maybe where to hone in on for statements and possible warnings. So now we're going to look at a couple different satellite animations again. The more typical visible loop, the channel 2 imagery, the red visible, is on the left. And then a product that's gaining a lot of popularity is the day cloud phase. It's an RGB product, looping from 14 to 19Z. I would highly recommend the RGB product, not only for these snow squall scenarios, but for convection in general. As you can see, compared, although you get some idea in the traditional visible of the cloud enhancements, it really jumps out at you on the RGB loop. As these cloud features are growing taller and you're getting more glaciation at the higher levels, with the ingredients that go into the RGB loop, you can see that red and orange tint. So it really jumps out at you nicely what the developing convective features are versus the lighter blue shading, which is the flatter, more laminar stratocumulus features. Again, could be another clue to tip you off on what really are the features of interest. And so I kept that same RGB loop on the right-hand side, and I'm comparing it now to the channel 5 imagery, which is the snow and ice channel on the left-hand side. Again, the RGB loop does a really good job of picking out the higher cloud features, and I'll go back here. One good thing about the channel 5 imagery is that if you have a situation where you have existing snow cover on the ground, it does a good job of discriminating that. If you look at a traditional visible loop, sometimes with the milky white shading of the clouds versus the underlying snow cover, it can be a little bit tough to tell. The channel 5 loop, the snow cover underneath is a darker shading. So there's some advantages there. And then again, for comparison, the RGB. And of course, there's the 1-minute mesoscale domain sector imagery. If you're lucky enough to have it, we were on this day. So this is a 2-hour loop of that RGB product in 1 minute. So now you can really get a good sense for how things are developing. And again, remember, these snow squalls can be we have this problem with lake effect snow too. Robust convection in the wintertime, but in the grand scheme of things, they're fairly shallow features. So you're going to have issues with radar overshooting. But if you can combine your radar analysis with satellite, you can get a more complete picture of how things are evolving. And again, this is the 1 minute for the RGB. And then I want to give a quick plug to the store page. Great training resource for satellite products. And I just grabbed a snippet here for the day cloud phase. You want to learn more about what goes into some of these different channels and the advantages. The store page is a great resource for satellite training on the fly in operations. So we'll do some more satellite comparisons. On the left-hand side is your clean infrared, your channel 13 loop. It's a default winter curve. And you can see some indication with the blue shades of the higher cloud level, but there's not necessarily a great differentiation. Again, we've played with here locally at State College, modifying that loop to be better at showing some of the features around maybe -20 to -25 C, which is where we see the cloud tops for some of these snow squalls. And those are in the progressively different shades of blue. So on the more colorful image on the right, again, these features of interest over PA, they jump out a little bit better than the more traditional curve would be. And then, much like with the RGB earlier, this is the 1 minute for the same time period of the infrared loop with our local color curve customization to try to show some of these more robust convective snow showers a little bit better. And then other tools that you can use. If you're lucky enough to have access to a state mesonet, which has some vertical profiling capabilities like New York does. These are, this particular station here is in Randolph. It's right on the PA-New York border. So when we're seeing squall potential or any kind of convective potential in the northern part of our CWA, and I'll step through different times, these profiles are updated every 10 minutes. So it's very good real-time sounding capability to augment the traditional 12Z, 0Z RAVs, and also the model soundings you would get. So this can be another tool if you're lucky enough to have access. So we could kind of see how the boundary layer stability was evolving that morning out ahead of these squalls. And then other tools that I'm not going to show here, strictly speaking, the infrared sandwich product. Some may be familiar. That's basically a visible infrared combination, and that could be a useful product. I hope that this is actually true. I think Dave had some new caps imagery to show its polar orbiter satellite soundings, and there actually are some gridded fields and AWIPs now. I was not able to grab any of that from our RWIS archive. I think Dave has some of that to show. It's another newer and interesting satellite tool that you can gauge the mesoscale environment in a pre-storm kind of sense. And again, that store page I showed earlier has nice resources on the new caps stuff as well. So this is just a static radar snapshot here early that afternoon, and I annotated the approximate position of where the Arctic boundary was at that day. This is with our newer reflectivity curve. And then the white star here, sadly, we had a pretty nasty multi-vehicle pileup on Interstate 80 associated with these squalls that day, and unfortunately had a couple of fatalities. And that white star is the approximate position in northern Union County of where that pileup was. And you can see it was right ahead of the front, and with those pretty robust convective snow showers. So what we've done is we've actually been working here the last couple of years to try to identify snow squall days that had these multi-vehicle pileups. And we're lucky enough to be one of the states in Pennsylvania. We have pretty good roadway, RWIS for short, roadway information system stations along some of our interstates. So the black box we outlined here, that is right around the time of that fatal multi-vehicle pileup on this day on Interstate 80. So the red curve is the surface temperature, the kind of light green shading is the visibility. And this is something we commonly see, is almost a spike in your surface temp and sometimes the visibility right ahead of these squalls. And then as the squall came in, the surface temp crashed. You went from mid-30s down to mid to high 20s in a hurry, which unfortunately enhanced the flash freeze potential, and you see the visibility crash to almost zero pretty quickly. So these squalls can come up fast. And some of this, by the way, was from a poster that one of our forecasters showed at this year's AMS conference back in January. So I give him credit here. And this is just an example of what the RWIS page for our Pennsylvania feed would look like. We can overlay all different kinds of data, radar data. We can get real-time webcams, road temp data plus air temperatures. There's some really nice features we can see here. They give us a sense for do we have perhaps a significant flash freeze component tied to the particular event we're looking at. This is also from the local research that we've done and was part of the poster that Mike Colbert from our office showed at AMS in January. So far, of these database of events that have had these multi-vehicle pileups, what you see on the left-hand side is we're seeing the air temperature and the road temperature. The gray is just prior to the snow squall occurrence in these multi-vehicle pileups, and the white box and whisker plots are what happens coincident with the squalls and the pileups. And what really stood out to us, the road temperatures are on the left, and look at that variance of roadway surface temperatures literally just minutes ahead of these squalls that cause multi-vehicle pileups. Sometimes you add roadway surface temps that were as warm as the mid to high 40s or even the lower 50s, and look at how quickly that drops. So when you've got cold air temperatures, even if the roadway is fairly warm ahead of time, and you get these squalls that come in, you can still have a lot of problems. And so as our research evolves in this area, this is really good information that we're passing on to our transportation partners, the Pennsylvania Department of Transportation and the Pennsylvania Turnpike Commission, to make sure that they have the proper situational awareness, not to let your guard down just because you have warm road temps on a cold day out ahead of these squalls. So again, some quick thoughts as I'm getting ready to hand it off to Dave here. These snow squall events can be very challenging in real time. The radar signatures can be subtle, they're low-topped, they're fast-braking, and really what determines in the end the severity with public impact, it's a complicated interplay of the meteorology and the transportation and roadway dynamics, i.e. the flash freeze. So we continue to learn more about these events as we get more experience. The key is maintaining good situational awareness. It's easy to get caught behind the 8-ball. Included in that, of course, is making sure you have enough eyes in ops that day. In some regards, these can even be a little bit trickier than your warm season convective counterparts. So making sure you have enough people and taking advantage maybe of some of the newer tools and visualization techniques that we talked about. And again, we're all still learning. And with that, I'm going to pass it on to Dave here, and he's going to talk about what happened a little farther downstream.
All right, thanks, Mike. You promised me -7 minutes here, so I think we're in pretty good shape. So I'll try to go as quick as I can through some of this. I think you all can probably see the screen now. I see it on the other screen, so I think we're good. All right. So again, for us down here at WFO New York, this really, since the Snow Squall warning products made their way from experimentation into operations, was really only about the second or third Snow Squall day that we've had. So we've not had quite the opportunity in terms of number of events that some of our colleagues have had kind of north and west of us. But overall, this turned out to be a pretty good forecast and warned event for us. You can see here one of the New York mesonet cameras on the top of Hunter College, kind of in Midtown, in the span of about 15 minutes there, shows, looking southwest, the impact of what was really the leading edge of a pretty well-organized mesoscale convective system on the sort of leading edge of the Arctic front. This event garnered quite a bit of media attention. Part of it was, kind of early in the season, really, early in the winter season, kind of in early mid-December, and did garner quite a bit. It was also WIA alerted for us. As you can see there, kind of in the middle, the New York Times picked up on that. Maybe it was a slow news day, I don't know. I think my favorite up there is the Snow Squall micro blizzard that some news media kind of made reference to, but nonetheless, we did see quite an interesting event once things moved into the area. In some ways, this was a pretty classic setup for organized snow squall warnings. As Mike has pointed out, we were sort of on the cyclonic shear side of the 500 millibar jet, steep low-level lapse rates with that air mass, low-level frontogenetic forcing, surface pressure couplets. So these are kinds of the things that we were kind of on the lookout for. And for us, really, although there were a couple of additional snow squalls around that day, for the most part, we really had just a single organized convective structure that we were paying most attention to here on the late afternoon of the 18th. The day before, so on Tuesday the 17th, I can remember walking out onto the ops floor and talking to the forecasters that day, looking ahead to Wednesday. And so our AFD, even the day before, was alluding to the fact that we were kind of in the pretty good setup for snow squalls. On the morning of the 18th, we had done some social media outreach to try to let folks know this is what we were sort of anticipating later on in the day. There was a chance. And so we did do a push for that kind of earlier in the day on Wednesday. Again, Mike already showed this. I will just point out that we did have 110, 120 knots at 500 millibars just kind of overhead. And again, by about 18 to 21 Z on that afternoon, you can see the boundary at the surface kind of making its way into southeastern New York. And again, the air temperatures and dew points behind that in the teens and the low dew points in the low single to negative values kind of behind the front. So that was sort of the air mass. Pressure changes again, nothing to really write home about early on in the afternoon. You do have sort of a wide-scale pressure couplet kind of in this general vicinity. As we get on later on in the afternoon from the New York mesonet, again, you see the pressure rises there by about 2130 Z, kind of in the wake of the advancing front. And you do see a little bit down here in the area that I have circled in and around New York City, the time the snow squall was actually sort of moving through, a little bit of a convergence down there, as indicated by the mesonet data there, as this thing was impinging upon the city. Low-level lapse rates, again, this is earlier in the day. You can see maximized here on the order of 6 to 8 degrees Kelvin per kilometer. And again, sort of maximized to our north. But as the afternoon went on, we would see our lapse rates certainly become more favorable down this way as well. Early morning sounding from here at the office, 0.21 inches precipitable water. So that was sort of the environment there. And again, you can see low-level, pretty dry, moist adiabatic sort of here in the lowest couple of thousand of meters. 18Z HREF, and this is farther upstream in and around Kennedy, but you can see the forecast for that afternoon was lapse rates pretty favorable there, in the lowest several kilometers, indicative, as Mike has already pointed out, of the convective potential. One thing that we did not necessarily look at the day of, but one satellite-derived parameter in addition to some of what Mike had talked about in terms of trying to better assess the low-level stability. So take a look at the new cap soundings. These, again, are available for the east, typically between about 17 and 18Z every afternoon. And the advantage in these kinds of situations is you often will get holes in the clouds or some clear areas, which doesn't contaminate the soundings. But you can see here in the vicinity, just out ahead of the Snow Squalls to the north and west, you can see pretty good lapse rates, single-digit values of CAPE, at least based on the satellite. So again, nonetheless, sort of giving you a little bit of confidence in terms of the convective potential on this afternoon. One of the things that I personally like to look at, whether it's wintertime or not, is some of the short-term cams, the HREF output, and this was from the 12Z run that morning. And again, the sort of postage stamp that you can see, again, not so much organized, but in the way of convection, but you do see by about 20Z, several of the models were sort of picking up on the leading edge of the Arctic front in some sort of organized convection, kind of making its way into the area by that afternoon. Even the newer version, again, by about 20Z, seems to indicate stuff making its way into our area post 20Z on that afternoon. Mike already showed this. Again, Snow Squall parameter. He showed the loop. This is just a single shot from the wrap earlier in the day. Again, highlighting kind of the combined potential from all the different, from the 3 or 4 different ingredients that go into the Snow Squall parameter. Again, highlighting the favorability on this particular day. Mike pointed this out. I think this is kind of interesting as well. You can see the leading edge here, and you'll see the radar pop in over that as we get on into the afternoon in 19 and 20Z. You'll notice that the day cloud phase does get red, those red shades, by later on in the afternoon as we start to lose the visible channel. And so while you can use this earlier in the day, certainly upstream, let's see if this will play again, to kind of pick out the more favorable areas up here where you're seeing some glaciation and those sorts of things. Once this imagery was down in our neck of the woods, and you started to lose some of the visible channel contribution to the RGB, it did lose utility in terms of being able to sort of keep that on situational awareness-wise. But again, here's just the radar shot here. You will see, and this should start to loop, you will see, or you won't see, some 30 to 40 dBz, let's see if I can back this up, some 30 to 40 dBz values as this pretty well-organized swath makes its way towards New York. It's telling me it won't play. But again, this whole thing maintains intensity really as it makes its way to the south and east over the next hour or two, traversing southern Connecticut, New York City, northern New Jersey, and much of Long Island. Our first snow squall warning of the day went out at about 3:24, and you can see a pretty wide area. Again, given the fact that we were anticipating this to start impacting the area by about rush hour, and so we had some pretty good lead time on this in terms of trying to get this out before the evening rush. And again, you can see subsequent follow-ups by 4:11, and just after that, kind of maintaining as this was going to impact most of this, southern southeastern portion of our CWA as the afternoon wore on. Again, this was WIA alerted, and that very first snow squall warning, that's what garnered all the attention given the 50 million people that were under that warning. Taking a look at both the ASOS and some of the mesonet stuff, again, you see sort of the characteristics as this thing went through. Temperature drop of almost 8 to 10 degrees. Dew points jump up. Winds jump up 30, 35 miles per hour. Kind of behind that is the wind shift. And you can see from the Central Park ASOS, you can see the reduction in the visibility over the course of a few minutes, going from 10 to a quarter of a mile or so as this thing went through. Taking a look at the time lapse again here, a couple of things I'll point out. Again, these are 5-minute time lapses. Again, this I think is Park Ave. But you can see, again, given the time of the day here, traffic is already sort of in and around the city. Traffic is already sort of at a standstill. So in terms of impacts, people were pretty much at a stop as this thing sort of blew through. So, kind of interesting to think about the fact that we have gridlock here pretty much every afternoon as the evening rush goes on. And so in terms of traffic accidents and impact, at least in and around the New York City area, those potentially are minimized, at least by the fact that folks necessarily aren't moving all that much in the rush hour time frame. So that was one thing that certainly worked, I think, in our favor that day, is the fact that we had traffic that already sort of stopped as this thing moved through. If we look farther to the east, out on Long Island, Stony Brook, which is on the North Shore, it's a good 50, 60 miles east of New York City. Again, same sort of thing, albeit an hour or so later. Again, you had the temperature drop, along with a jump up in the dew point, and the gusty winds 30 to 35 miles per hour as this thing sort of went through. And again, just another perspective, you see the flag kick up here. We're looking southwest, and you'll see this thing come through on the order of 15 to 20 minutes, and then it's done with a little bit of snow on the ground. So pretty quick moving. Didn't show too much in the way of road temperatures that day, like Mike did, but a cursory view, we actually had road temperatures that day, particularly in northeast New Jersey, into the low 40s. And as this thing came through, those temperatures dropped about 15 to 20 degrees to below freezing shortly after the event. Taking a look at some of the probability of freezing road temperatures, as you would expect. Again, this is 17Z earlier in the afternoon here to the upper left, 21Z down here in the lower right. But again, as you would expect in that 3-hour period, as that air mass came through, along with the precipitation, higher probabilities of those freezing temperatures for the roads that afternoon. So that was one thing that we were kind of watching as well. And again, sort of fits into the entire narrative here with respect to the entire event. Lots of interesting comments on social media from this event. Again, given that it was really the first wheel one that we have had, folks not understanding necessarily what it was, or kind of surprised maybe that they got an alert. Again, some partner education here in terms of keeping folks on top of what these are and aren't. I think is something moving forward that we're certainly going to pay attention to. So, again, as Mike sort of alluded to, we're still sort of learning about these. Again, this event, for the most part, was a pretty classic setup. Taking a look, in addition to what Mike showed, perhaps some use of newcaps and satellite-derived soundings and/or winds as supplemental information in sort of this, total observing concept kind of scenario here, where we have, satellite and mesonet, and surface obs and radar and cameras that we can sort of use to get a handle on what's actually happening, but we're still learning. I think one interesting thing to think about, and Pete Banacos had a talk at AMS on this, is whether or not there's some capabilities here to use satellite information for verification in terms of satellite winds, for example, and that sort of thing, scatterometer winds, and that sort of thing. So some interesting questions, I think, going forward to think about with respect to some use for satellite information for verification. And that pretty much sums it up. Again, I think as Mike alluded to, we're still learning about this and learning some, trying to get our arms around some best practices for issuing of these warnings. And as time goes on, we will continue to experiment and learn. So with that, appreciate everybody, and we'll turn it back over to Scott and Dan.
Okay, thanks to both of you. Are there any questions for our speakers?
Hey guys, this is Ed up here with Dan and Jarrell. Since you have so many millions of people there, And we just got a glimpse of some interesting commentary that you had on the screen. What can you summarize maybe what some of the feedback is? People still kind of confused? Are they, and what can be done to help out with that? About the Snow Squall thing.
Yeah, I heard. Is that who is it? I could sort of hear the question.
Oh, okay. I'm sorry. This is Ed Zoke, and I'm up here with Dan. I was wondering what if you could summarize. Maybe you probably got an enormous amount of feedback. Some of it looked pretty interesting on the screen you showed. What's the main gist, or is there one?
Yeah, I think from what we heard, I think for this particular event, at least our emergency manager partners, for the most part, were pretty happy with the services that we provided. I think there's some education that we still need to do with respect to the timing and the short duration of these. In other words, the quick-hitting nature of them. I think, it's kind of interesting. Out here on the island, folks had already been noticing what was going on well to the west via social media and other outlets. And the warning out here, folks were sort of almost waiting for the thing to come. It was almost like the warning was too early out here. Some folks were telling me, and it was sort of, kind of interesting to think about that folks were sort of waiting for this thing to come with a warning that was out ahead of time. So far ahead of time in some cases. So, I think those are some things, and part of it's been media education as well. There was obviously media interest. But again, it's sort of, trying to draw the analogy between warm season convection and cold season in terms of the, sort of space and time duration of these kinds of events. And keeping the focus on, the quick hitting but potentially impactful depending on, whether you're, going 70 on I-95 or sitting in your living room. I mean, it's clearly different. So those are some of the things I think going forward we need to continue to work on.
Are there any other questions or comments?
Yeah, hey Scott, it's Brian. For both cases, were there any lightning reported or any special wording for people outside?
This is Mike in State College. I did look to see if there was any, even in cloud, and I don't recall seeing any for this particular event.
Yeah, I went back and looked at GLM. I didn't have access to any point data archive that went back that far, but a quick look back at the GLM didn't show much, even, which is, I'm sort of surprised, even for the sort of more organized, when you have, 35 to 40-ish plus DBZ, and I was sort of surprised, but not much in the way of lightning activity for the more organized one either, Brian.
Okay, thanks, Dave.
Hey, Dave, this is Rose at Eastern Region. It's really impressive how much advance notice there was, for so many million people. I mean, that's pretty amazing in my book. Now, having been through, what seems like a classic event, and, as much as you all looked at and had yourselves advance notice, if you would see another case like this developing, what would you do differently or in addition?
Yeah, I think, it's a good question, Rose. For us, this, for everybody, not just us. I mean, these warnings are really the definition of impact-based, right? The result is very different if you're going 75 on I-90 versus sitting home on your couch. And so I think we just need to be really careful about when we're issuing these, again, to keep our eyes on the fact that it's the impacts that we're worried about, not necessarily the phenomenon. So, if depending on time of day, depending on whether or not, there's a major roadway that's going to be impacted, these are things that maybe we're not quite so used to doing with other sorts of warnings. or at least maybe weighting those quite as heavily than we would for something like this. Would we do anything different for this event? Probably not. I think, for the most part, we had, advanced warning for rush hour. And even though you had, slow traffic in and around, your typical, New York City gridlock, you did have points north and west where you do have, people traveling and commuting. So, I don't think in this case, we probably wouldn't have done anything drastically different.
Yeah, Rose, I'll add to what Dave said. I'm not sure we would have done much different either. It was a little bit earlier in the day for us, and we've always got the terrain and the high-speed interstates going through there that are problems. I guess the one thing, and this goes more to the learning component and some of what Dave said, what really drives these things are the impacts. So I think what we're trying to get a handle on collectively is when are we going to see this flash freeze component? Because you could have a heavy snow shower go through with all the meteorological components of what typically might comprise a squall, but if you don't have the flash freeze, what are the impacts? So I think that's, we're trying to learn how the meteorology plays with that and getting better at when we have both of those at the same time.
Yeah, that's interesting. And, there's only so much you can do, I think. I mean, here in central Long Island, as you might expect, with a an office full of meteorologists, we sat there, glued to our windows, and I ran downstairs to the, first floor and watched. And as people were coming and going, there really wasn't any awareness as you might expect. So, do you make a big effort, to alert the general public or find a way to do that? Versus, as you say, in the context of impact. So, those kinds of awareness issues, I think, remain to be seen.
This is Ken Johnson, Eastern Region. Both Dave and Mike, question regarding satellite data. If you had a wish list for these kind of events, is there any other kind of satellite product or data that you would like to see, or data fusion that would include the GOES data?
Boy, Ken, this is Mike here. I'd have to give that one a little bit of thought. I don't have an immediate answer to that question, but I'm sure there are some ways we could optimize fusing different products and visualizing them that are a little bit improved to what we have today. Although I think our repertoire is grown by leaps and bounds the last couple of years, but I guess I'd have to give that one a little more thought. I don't know if Dave has something more at the front of his mind.
Yeah, hyperspectral sounder on the new GOES. I say that sort of writing the check for how many millions. No, but to be fair, if we're being serious about low-level evolution, boundary layer evolution, and lapse rates and moisture, kind of keeping both for warm season and cool season, anything that we can do to sort of help get a better snapshot, on the order of, minutes to, tens of minutes, I think is going to certainly help. So, short of that, additional soundings as we have them. That's one way. I've started to think about some of these other products we've seen over the years that are sort of satellite derived. The problem is, either they have too big of a spatial footprint to be of use for this kind of, mesoscale spatial phenomenon, or they don't have space and time, really. Or something like a day-night band might be kind of nice, too, to monitor these things as the sun goes down. So for the example of the RGB, which we lost right by losing the visible channel as time went on that afternoon, you could fuse a day-night band on a geo into that product, right, and not lose a visible channel, and does the product utility as you lost the traditional visible channel. So that might be another option as well.
Yeah, Dave, that's a really good point with the a day-night band. That would be particularly useful for the near your sunrise and sunset points. And I think this satellite discussion is these are one of the phenomenons that it's really critical, because in the absence of resurrecting a lot more radars than we have in our network right now, we're always going to have these overshooting problems. So I think the satellite sensing capability is super important for a phenomenon like this.
Okay, thanks, guys.